I know it looks like a lot, but it's really more logical and it makes more sense than you would think. So you can stop the video and copy this list of 5 rules that circuits always follow. But let's go over it. So the first one is that the current is constant in a particular branch. So if you have some current at the beginning of the branch, it has to be the same as at the end of the branch. The current doesn't leave, it doesn't go anywhere in a branch. The second one says, when the current splits into 2 branches, the sum of the 2 currents is equal to the current before it splits. So basically, if you have one branch and another branch, if you have some current coming here and then it splits between this branch and this branch, the sum of the 2 is the same as the current that came in before it split. The third one says the current leaving a battery is equal to the current entering it. So current is never lost, basically. The current leaves the battery, it splits into the branches, then it comes back together on the other side, and the same current will enter the battery on the other side. The fourth one says the sum of the currents in all branches is equal to the current leaving the battery. So that's basically just the same thing. The current from the battery splits into all the branches, so if you add all the branches, it's going to give you the same as the current leaving the battery. And the fifth one is about voltage, and it says the voltage in each particular branch is equal to the voltage of the battery. So with voltage, it's different. It's not that when you add all the branches, it adds up to the current of the battery, which is the case for current. But in voltage, every branch has the same voltage. So I'm going to draw an example that hopefully will make these 5 rules become more clear and easy to understand. So this is an example of a circuit that has 3 branches. The first branch has 2 lamps, the second branch has 1 lamp, and the third branch has 3 lamps. So the current will go out of the battery, it'll go out in this direction to the left, it'll go down this part, and it'll divide. Some will go through the first branch, some will go down, and then it'll divide between the second branch and the third branch. The current will pass through these lamps and go back up. This one will pass through this lamp and go back up, and this one will pass through this lamp and go back up, and it'll all meet together again here and go back into the battery. So basically the current is going to be making a circle. Some of the electrons will choose to do the small circle, some the middle circle, and some the big circle. So I'm going to give you some values of current, and using the first 4 laws, the ones related to current, we're going to try to figure out the rest of the currents in the other places. Okay, so the idea is the following. I gave you 3 values of currents. The first one is the current leaving the battery, which is 0.9 amps or amperes. The second one is the current that chose to go through the first branch, which is 0.4 amperes. And the third one is the current that chose to go through the third branch, which is 0.1 amperes. And in every orange question mark, I want to figure out the current by using these rules. So what can I do? Let's see what the first one helps us with. Current is constant in a particular branch. Okay, so for example, I have this current of 0.4, and this question mark is in the same branch. So that means that because it's constant in that branch, that question mark has to be 0.4 as well. So I'm going to put here 0.4. That also happens in this one. Notice that 0.1 is part of the same branch as this orange question mark over here. So this one, I can change it for 0.1, just using the first rule, 0.1 amps. And I think that's it for the first rule. The second rule says, when the current splits into 2 branches, the sum of the 2 currents is equal to the current before it split. So we have to figure out somewhere where it splits, and we know 2 of the values, and we're figuring out the third one. So here we see that there's 0.9 amperes going in here, and then it splits. 0.4 goes this way, and the rest goes down. So we have to subtract. If 0.9 came in and 0.4 went this way, then 0.5 went down here. So this has to be 0.5. The same thing happens in this division. 0.5 came down, 0.1 of those 0.5 decided to continue down, but the other part went to the right. So in this question mark, we have to put the subtraction of 0.5 minus 0.1, which is 0.4. The other one that we can do that with is this one to the right. So here the 0.4 and the 0.1 will combine, and they will add up to this new current, which has to be 0.4 plus 0.1 is 0.5. So this one is also 0.5. And that's all we can do with the second rule. The third rule says the current leaving a battery is equal to the current entering it. So the current leaving was 0.9. So that means that the current entering it, which is this last question mark that we have left, has to be the same. So if it's 0.9 to the left, it has to be 0.9 to the right. And that's it. We figured out all of the currents using the rules. The last rule of current tells us the sum of the currents in all branches is equal to the current leaving the battery. So let's check that. We have, in this branch, we have 0.4. Plus, in this branch, we also have 0.4. And in the last branch, we have 0.1. So this is going to add up to 4 plus 4 plus 1 is 9, 0.9. And that's exactly what the current was leaving the battery. So this is right as well. Right? So that's basically how we can use the current rules. Now I'm going to do an example to know how we can use the voltage rule, which is just one, so it's a little bit easier. Okay, so here I drew another circuit, a completely different circuit, that has also 3 branches, but it has 3 lamps on the first one, 1 lamp in the middle one, and 2 lamps at the end. And the only value we're given is the voltage of the battery, which is 5 volts. So imagine we have here a 5-volt battery, and we want to figure out the voltage in different components of the circuit. So I have to draw them as separate branches because if you remember, voltmeters have to be connected in parallel. So they have to be not on the same branch, like here, that every arrow could be an ammeter to measure the current, but it has to be in a separate branch. So I'm going to draw the ones that I want us to figure out. In order to figure out the question marks, the values of the voltages around the components that the orange question marks have, I had to give some more data. So I'm going to say that the voltage around this lamp to the right is 1 volt, and the voltage around this lamp down here is 3 volts. So let's look at what our circuit rule tells us. The 5th rule says the voltage in each particular branch is equal to the voltage of the battery. That means that if the voltage of the battery is 5, the total voltage in this branch has to be 5. The total voltage in this branch is also 5, and the total voltage in this branch is also 5. So all of the voltages have to add up to 5. So here we have 1 volt, and we're missing the rest. The other 2 components are part of the other voltage. So if we have to add up to 5, this has to be a 4. 4 volts. This one, this is the only component in that branch, and it has to add up to 5. So the only choice is that this whole thing is 5. And down here we have a component of 3 and a component that has to add up to 5. So this other component has to be a 2. And finally we have this one. This one covers both components. So it has to add up. If this is 3 and this is 2, the whole branch has to be 5. So this one is 5. So that's it. Basically, I'm going to give you examples of circuits, and I'm going to ask you to figure out the current using the first 4 rules and the voltages using the last rule.